And in today's episode, we're going to be talking mostly about adding and subtracting expressions that contain variables. Now, in order to add and subtract expressions containing variables, I first need to talk to you about something called like terms. Now, for a warm-up exercise, let's suppose that the variable x stands for an unknown number. Let's write down an expression that represents taking three copies of x and adding them together. So if I have x, x, and x, three copies of those, and I add those together, this would be one way to represent this instruction as an expression, x plus x plus x. But we remember that multiplication, the meaning of multiplication, was to represent repeated addition. If you add a number to itself three times, the alternative way to represent that action was as 3 times x. 3 times x represents three copies of x added together. By contrast, if we wanted to represent three copies of x multiplied together, the action of repeated multiplication was represented using an exponent. So if I wanted to say three copies of x multiplied together, my shorthand for that was x cubed. So be careful when you're dealing with expressions containing variables about the position of the numbers in that expression. If you have a 3 in front of an x like this, 3 times x, what this represents is three copies of x that have been added together. Whereas by contrast, if the 3 is located above the x as an exponent, what this represents is three copies of x multiplied together. And I think if you bear in mind the meaning of 3 times x, it can help you to simplify expressions that look like this one, 3x plus 5x. This 3x in the front, 3 times x, represents three copies of x added together. And this 5x in the back represents five copies of x added together. So if I have 3x and I have 5x and I add those expressions together, what I am essentially doing is taking a pile of three added x's and putting it in a pile with five other added x's. And in total, I have 8 copies of x added together. But 8 copies of x added together can be represented by the multiplication 8 times x. So in other words, if I have 3 times x plus 5 times x, then those can be combined into 3 plus 5, 8, 8 times x. However, if I made a little bit of a modification to this expression, if I had, instead of 3x and 5x, if I had an exponent on one of those x's, now it becomes a little bit harder to combine these two piles, right? Because this first pile is three copies of x added together, but this second pile is five copies of x squared added together. And so what I'm essentially trying to do here is combine apples and oranges. I have a pile of three objects and another pile of five objects, but those piles are not the same object. So it's not like trying to combine one pile of 3x's with another pile of 5x's, where the piles that you are combining are two piles of exactly the same object. We have the following terminology to help to express the difference between this situation and this situation. In in mathematics, when we use the word term, the word term is used to express a product of numbers and variables. So something like 3x would be a term, something like 5x would be a term, something like 5x squared would be a term, something like 7x would be a term, something like 2x would be a term, because all of these are products. 3 times x, 5 times x, 5 times x, and so on. All of these are products of numbers and variables. This number in front of the product is called the coefficient. The coefficient. So for example, in 3 times x, the number 3 would be called the coefficient. In 5 times x, the number 5 would be called the coefficient. In 5x squared, the 5 would be the coefficient. Here 7 would be the coefficient, and here 2 would be the coefficient. And now that we have talked about what is a term, and we have talked about what is a coefficient, I can tell you the important definition for today of what is a like term. Two terms are called like terms if the only difference between them is their coefficient. Two terms where only the coefficient is different and every other aspect of the term is the same. For example, 3x and 5x are like terms. Because if I look at these two terms, the only difference between these terms is the coefficient. One of them has a 3 in front and one of them has a 5 in front, but everything else here is exactly the same. 7x and 2x, these terms are like, because the only difference between these terms is the coefficient. One of them has 7 and one of them has 2. However, 3x and 5x squared are not like terms, because it's not just the number in front, it's not just the coefficient that's different. The number of x's is also different in these terms. One of them has an x and one of them has an x squared. So somehow there is a relationship between having like terms and being able to combine those terms into a single term, to combine those two piles into a single pile. If the two terms were like 3x and 5x, then I could combine them into a single term, 8x. However, if the two terms were not like, then I was not able to effectively add those two piles together and combine them into a single pile and into a single term. If I wanted to think about like terms visually, if I wanted to think about, for example, 4x versus 7x squared versus 3x, for example, The way that I might think about four x's is as a pile of four straight lines, representing each x by a straight line segment. And likewise, this pile of three x's would be a pile of three lines. But this pile of 5x squareds, I might think about as a pile of 5 squares. If I think about 5x squared as a pile of 5 squares, then visually I can see that it doesn't make sense to combine this pile with a pile of 4 line segments or a pile of 3 line segments, because these are not similar piles of similar objects. However, it would make sense to combine this pile of 4 sticks with this pile of 3 sticks. Those are similar objects, so I could put them into a single pile containing 7 sticks, or 7x in total. Let's get a little bit of extra practice identifying like terms versus terms that are not like. If I had 6 times y and 6 times x, are these two terms like? These terms are not like because even though the numbers in front match, the thing that we need to match is the stuff in the back, the variable part. Here I have a pile of 6 copies of y. Here I have a pile of 6 copies of x. So these are not piles of exactly the same object, a pile of y's and a pile of x's. 5x and 3x. The only difference between these terms is the number in front, the coefficient. So these are like terms. Here I have a pile of 5x's and a pile of 3x's. So these could be combined into a single pile of 8x's. Here, if I have 4 times x and 5 times x squared, are these like terms? No, they're not, because the coefficient is not the only difference between them. The variable part is also different. Here I have a pile of 4 x's, but here I have a pile of 5x squareds. So these are not piles of the same objects, so these are not like terms. Here I have a pile of 7x, and here I have a pile of 7 copies of x squared. So these are not like terms because the variable part in the back does not match.